welcome back. SPV Bridge to College Math. This week, welcome back from spring break. It would be neat to either wrap up Unit 5 or if you're tired of doing systems of equations, let's move to Unit 6. And Unit 6 is exponents, exponential functions, and logarithms. Okay, how do we solve when the variable is the exponent? And these are really important in times like this because, like COVID was an exponential growth for a while. Okay, don't forget, anytime you need a video, you can just go to the Bridge to College Math Teams channel, and up in the top you'll see the stream channel. That's where I house all these videos, so if you ever need one of the older ones, just go there to find it. Okay? Alright, let's get started. So we got to find the internet, and we got to find Spokane Public Schools, and we got to find Clever, and we got to find Blackboard, and we got to find our Bridge to College math class. Alright, so don't forget, each week in the announcements, that's where you'll see the video that's been posted after I make it. And most of you have been working on Unit 5, Systems of Equations, where do lines intersect. If you're tired of that, feel free to move on to any of the other units. I'm going to go kind of in order, and I'll do a couple from this one, a couple from this one, and a couple from this one, and a couple from this one. And the next thing you know, school's going to be over because we've only got, 10 weeks left? All right, so let's go to exponential functions, and we're in growth and decay. Growth and decay. So I'm just going to click on this one, and if you don't remember any of these type of functions, I love the way this one reads. If you earn $3,000 every year, it grows linearly. But if you have an exponential growth like any of these, it's going to be a little bit different. So let's just click on a growth and decay one, and we'll work on it. Okay? All right. So together, for each of the situations below, set up a table, write a general formula, and sketch a graph to represent the output in terms of input. Okay, North Dakota has recently had fastest growing population of all the states in America. January of 2013, the population was 700,000. North Dakota's population has been growing at 5% per year. Express North Dakota's population in terms of years since 2013. All right. So, growth model, right? We're going to grow. Air freshener starts with 30 grams of fluid, and the amount of fluid decreases, so decay. All right? Okay. So, if in doubt, and you need an equation for growth and decay, you just go to Google, go to Bing, and just type in exponential growth and decay functions, and here's our function. Okay? And I did a screenshot of that, and let's define some terms, okay? All right, so when we get started on this, the first thing we're going to do is see that we have the final value of money. I always relate to money. Okay? And A sub 0 will be the initial amount. And we have plus or minus. So, plus for grow, minus for decay. R is the rate. Now remember, when we work on rate, they always give it to us in percent, but we have no percent button on these calculators. There's no percent key. So you got to remember, you take the rate, okay, divide by 100 to get the decimal version, right? Move the decimal over 2 places, okay? So for instance, 5%, 5 over 100 equals 0.05, all right? And we got T for time. All right. So let's go back and see the first problem here. All right. So our first problem was, 700,000, 5%. Okay. So the first problem, number 1, the final value is going to be the 700,000, the initial value. It's a growth, so 1 plus 5%. So what do we got? Start value 700,000 plus for growth 5% is 0.05, so 0.05 for t years. There it is. Okay, now you go ahead and work the problem since 2013, right? So here's our value. Perfect. Okay, so now it wants you to sketch a graph. Okay, so then you would just go ahead and you could create some sort of a template, right? And we start with 700,000 and it's going to grow over time. All right. The second one is decay. Okay, so decay, our start is 30 grams, 12% per day. R is 12%. So 12 over 100 equals 0.12 after t days. Okay, all right, so our final value is going to be our initial value, and it's going to be minus decay. Decay is a negative, so 1 minus 0.12 for t days, right? And we're going to start at 30. This one started at 700,000, and it decays. Okay, growth and decay. So feel free to work into those. Next week I'll work on a logarithm problem. Might be some identities for logarithms, but we can work on that, or I can shoot you a cheat sheet, whatever you need, or Google it. Welcome back from spring break. Don't forget, we are Bridge to College Math, SPV, and if you're tired of systems, go to Unit 6, or pick any problem from any of the units. All right? If you need anything, reach out. Monte signing off. Welcome back from spring break.